This is Algebra 2 with trig. We're looking at using the calculator for several of the problems. This is 1b.4. Okay, some of our I can statements is that I can find the key points of a quadratic using a graphing calculator, and I can write a quadratic function in standard form given at least 3 points and using a graphing calculator. So we're looking at this first situation. We're going to have a water balloon that's launched from a dorm room. Its height in feet after t seconds is given by this equation. So I think Kelvin is throwing a water balloon at Lucy. So we're going to take our graphing calculator and we're going to type in 128 plus 64t. Now where you get the t, we're not actually doing a t, we're doing an x. We can't get the calculator to show a t in this format of the y equals. So that's just the variable that we need to use, and minus 16t squared, which is we're using x. So when we graph this, you'll see that it falls way off of our screen, but if we hit our second button and graph, you're going to go to a table, and the table tells us a lot of information. At 0 seconds, we're at 128 feet. One second, we're at 176, 192, back to 176, 128, 48, and at 6 seconds, we're already under the ground at negative 64 feet. So mathematically, we know we can't go. Well, mathematically, there is a t value that gives us negative 64, but a water balloon can't go down underground. So why does the table stop after 6 seconds? And I would say that mathematically, the balloon is underground at 6 seconds. So there's no need for us to go past that, because somewhere between the 5 and the 6 is where the y value became 0. We don't know where it is, but between the 5 and the 6, we'll find that later. Looking at your window, so if you take your graphing calculator and hit the window button, you'll see what the standard screen is. If you don't have this, you have something that's much different. I'll just throw in some crazy values. If you have something that's completely different, you can hit the zoom button, and we look at number 6, called zoom standard, number 6, and that'll put it right back to our normal window. So hit the window, and we're right back to what we started with. So our minimum at the current window, our minimum is negative 6 for the x. That means we're looking negative 10 for the x values. The maximum x is we're looking at x values up to 10. And the scale is 1. Which means that each of these tick marks in here is 1, and in our case, 1 second. The minimum y value for what we have originally is negative 10. The maximum is 10, and the scale, you'll notice, is 1. And when we look at the graph of that, we can actually count and see those different dots. And here we can see the different dots. And those are your scale that the graph is using. But we can't see the whole graph. So by looking at the table again, it's also written at the top of your page, we'll be able to see what the values are. So at 0 seconds, we're 128. That's what we wrote up there. We're going to go all the way up to 192. So we need to have a window that's more than a y value of 192. I would suggest like 250. Get it plenty of the way up there. Any number bigger than 192 would be good. If you pick exactly 192, then your graph would be right up to the edge of the top pixel, and it's just sometimes kind of tough to work with, especially if you were to start to work with different values. The equation gets in the way of it. So if we come over here and call that 250, it gets it well down below having any equation get in the way. Okay? Our minimum, we can leave that at -10. That's typically pretty good. Now, when we looked at our table, we had an x value that went up to 6. So we don't need an x value to be much more than the 6. So we could put 8, we could put 7, we could leave it at 10, doesn't matter. Minimum. Well, minimum, we don't need to go over here in the negative zone at all. So we could put 0. You can also put -1, so you're sure to be able to see the y-axis. The scale, still use 1. And maybe your scale on this side, we could try changing it to 50. So we'll say -1 for your minimum and 8 for your maximum. And your y scale is 50. And you now see that the y scale has a tick mark at every 50. We don't look very far to the left. And we look a lot of the distance. Between 5 and 6, we're hitting underground. So that's a good window for your equation to be shown. What is the height of the dorm room's window? Well, in your table, and you can see that at the top of your page, which one of these values is representing that? When the x value is 0, we can say x equals 0 or t equals 0. H of t is going to be 128. So the dorm room is your c value of your standard form. Okay, how do we know? I guess I kind of answered it there. We know that when t is 0 on our table, we get 128. It's our c value of our standard equation. Now we can find different points. We can look for our max and our min. To find our max or min, in this case, it's going to be a maximum. It's going to be the high point because our a value is negative. We're going to second trace. Looking at the maximum value, number 4 is your maximum. We're looking for a high point, so we're going to use number 4. Notice here in the left-hand corner that we're looking for the left bound. That means we have to be to the left of our predicted vertex. So use your cursor and go to the left of that predicted vertex. Anywhere to the left of that vertex. And hit enter. Then you'll notice it says right bound. So we're going to use our cursor and we're going to go to the right of that predicted vertex. And we hit enter. Now it says guess. Guess is used for if there's more than one possible answer. Sometimes we'll have that. But for a maximum point, we're only going to have that once in a quadratic. You can get closer if you want, doesn't really matter. Hit enter, and everyone should get an answer that's very similar to this. You'll get your actual maximum, and that'll be correct. But your x value can differ. Some people get 1.99999. Some people get what I have here at 2.00015. But it is still exactly 2. It's not this value. It's not the 1.99. It is exactly 2. It's just the way that the calculator uses the process to find the maximum value. So what is the maximum height? H of t equals 192, and those are in feet. You could see that in the table too, that it hit a maximum. Sometimes it's difficult to tell by looking at a table if the maximum occurred on a perfect second. But looking at the table, you can see that we have numbers that are being repeated. And that means that the vertex had to be in between 1 second and 2 seconds, or exactly in between, which would be exactly 2. If you plug in 2, you get the answer of 192. When does the balloon reach its maximum height? When the t equals 2 seconds. It's not that crazy decimal of 2.000015 or 1.9 or whatever yours had. It is exactly 2 seconds. Your table represents that better than the maximum. The maximum was just showing you the actual y value's maximum, and that value is correct. What is the height of the balloon when it hits the ground? Well, when we look on here, what does it mean by the height of the balloon when it hits the ground? Well, the height of the balloon when it touches the ground, of course, the ground's at 0. So h of t would be 0. At 0 feet is the height of the ground. Y value would be 0. When does the ball hit the ground? These are called the zeros, or the x-intercepts of the craft. When does the ball or balloon hit the ground? Well, we can't completely see what's going on here because we got some equation parts that are getting in the way. So if you go to window and we go to a y value that's a little bit further down, like maybe -50. Now when we hit trace, you'll see that that keeps out of the way. Trace is not a good way. We can use actually trace, and we'll get as close to 0 as we can. I'm at 5.5 for y. I'm at -5.1. I can't get 0. I can't get any closer. So trace is not a very good. It's just a little predictor, but it doesn't get us the exact answer. So for us to get that exact answer, we're going to go to second trace, which is to calculate. We're looking for the 0 of the function. Some people think of intersect, but you need 2 equations to do intersect. We're going to use the 0 function. Again, it's going to ask us this left bound. Well, you need to know some about the graph first. You need to know, what are you looking for? You're looking for the 0 of the function. So right here where my pencil's at is the 0. It's where it crosses the x-axis. I need to be to the left of this location. So anywhere here would be considered the correct left bound. It doesn't matter where I use. Hit enter. Now it says right bound. So I need to arrow over until I get to the right of it. Notice when I'm to the right of it, my y values are negative. That's because I'm below the x-axis. And I can hit enter. You'll see the 2 triangles at the top. That's showing you the domain that they're using to be looking between. They want you to guess. You really need to guess if there are more than one answer in between that domain. there's only one answer inside there. You could get closer if you want, but it won't matter. You can just hit enter, and it'll give you the exact 5.46 seconds for when it hit the ground. Now we're going to look for two other spots on the graph. We can go to Window, and we can see what our different values have been. We can go to y equals. We can see our equation. If we arrow down, we can put in a new equation. We'll just say 150. So we're looking to see where the balloon was at 150. So that's the height of 150. So if you can imagine a tree, and the tree might be 150 feet, did the balloon get over the 100-foot mark? The answer is yes. It was up there for that amount of seconds. But we're looking to see what was the time that the balloon was at 150. So we're going to go to Second Trace. We're looking for intersect this time. We're going to take the two equations and look for their system. It asks us here, is this your first curve? If you look at the top of your calculator, you'll see an equation. Is that the equation that you're talking about? The answer is yes, so I hit enter. Is this the equation that we're also looking for the intersection of? Yes, I typed it in. Of course it's right, so I hit enter. Now it says guess. This is kind of important. You need to guess while your cursor is at the point that you're interested in. If we're looking for this point over here, I need this cursor closer to the point rather than closer to that one. If I want this answer, which is where it crosses 150 on the way up, crosses 150 on the way down. If I want this answer, I'm going to bring the cursor close to it and hit enter. And you'll see that we get 150 at this amount of time. Well, this also happens another time. This also happens over here. So I can hit Second Trace, which is the calculate, go down to intersect. I have my first curve. I have my second curve. Then I'm going to scroll over and get closer to this intersect. This is the guess. I'm getting closer to the answer I'm interested in now, and I hit enter. I get 0.38. If I round that to the nearest hundredth, 0.38 seconds. So there's many times where we're using menus that are a little bit different. Sometimes we use left bound and right bound. Sometimes we use first curve, second curve. It would be nice if they had those written as first equation, second equation, but it all works. Here we're going to write an equation in standard form of a parabola that crosses these points. Let's do a little bit of an idea of what this might look like. -2, -6, here's one point. 0, 6 is another. 2, 2 is another. So somewhere this is going up, it's making a curve, it's going through and coming back down. We don't know if the 6 is the maximum. We don't know just how it falls in there. But those are 3 points on the parabola. None of those are probably the vertex. So we know that an equation is written in the form of ax squared plus bx plus c. We're going to need to write three equations. There's not a lot of room here to fit it, but we're going to write three different equations, one for each point. This is your y value, this is your x value. So we're going to plug the x and the y into our equation. So we have negative 6. I'm going to start further to the left, I'm sure I have enough room, equals a, because we don't know what the a value is, x squared plus b times our x value plus c, and we don't know what the c value is. That's for our first point. Well, we're going to repeat the same thing for each of these points. 6 is our y value, 0, now we can tell that our c value is going to be 6 because that's our y-intercept, so of course that's going to be at 6. They didn't have to give us that. Then we plug in our last point. So now we have these three equations. We're going to rewrite these equations kind of cleaned up. Take our negative 6 and equal that to negative 2 squared, which is 4a, minus 2b, plus the c. We come to the next equation, 6 times 0a plus 0b plus c. So of course c is going to be 6. 2 equals 4a plus 2b plus c. Now we could use substitution to work our way through these, but we can also use our calculator. Using our calculator, see if I can get a good screen up here for you. We're going to go to matrix. So the matrix button is right down here. It's right underneath the math button. So it's written in blue, so we have to hit the second and we have to hit the matrix. You get a screen that looks like this. Well, we're going to be editing what our matrices look like. So we're going to go over to edit and we hit enter for this A matrix. We have to decide what our matrix is going to look like. What the rows and columns. Well, let's talk about that. Here, we're going to make a matrix out of these coefficients. So we have negative 6, 6, and 2. We're going to put these brackets around it, which is called a matrix. I like to call that your answer matrix because this is what it's equaling, your equal matrix. Now we're going to take the coefficients from these three equations, the 4, the negative 2, and the 1, the 0, 0, and the 1. These are the numbers that are in front of the letters. The 4, 2, and 1. Put brackets around that. Now for what's called a matrix equation, we like to finish that off with the letters A, B, and C. There's a lot of work that we could learn about matrices and why this sets up and what does it mean to multiply this all together. But what we're going to do is type these matrices into our calculator. So our first one had 2 rows, I'm sorry, it has 3 rows and 1 column. 3 rows, 1 column. And you can see the way that it did it here in the calculator, it gave you a spot to type in -6, 6, and 2. Now, oddly enough, we have to get out of, let's see, go back to matrix. Sorry, then we're going to go over to edit, and we're going to edit the B matrix and hit enter. So now we're in the B matrix. Well, let me change this. Often we call this our A matrix, and this is your B matrix. I am going to have you redo that. We're going to call this our 3 by 1, and that's going to be our -6, 6, and 2. And when we slide back to second matrix, we're going to edit that A matrix again. And we're going to turn this matrix into the 3 by 3. It's just a tradition. Traditionally, you like to call this matrix your A matrix. Doesn't matter. We'd still get the same answer. But traditionally, I'd feel more comfortable typing in the numbers. So I'm typing in the 4, the -2, and the 1 into this matrix, the 0, 0, and 1, the 4, the 2, and the 1. So now we have that A matrix and the B matrix. For us to get the answer, it's like dividing it over here. Well, we don't actually divide. You can't divide a matrix. It won't work that way. What we need to do is say the A matrix times, well, we're going to take the B matrix times the A inverse. So we're going to get out of matrices. You need to hit second mode. That'll take you out of the matrix completely, because right now it's all stuck in that editing. Now we can go back to matrix. We'll take the B matrix times, back to matrices, the A matrix, and we're going to do the inverse button. That's the -1 button. That's right above the squared button. That's the inverse button. Erg. Okay, I said that backwards. Matrix A inverse times B. It does matter the order you type these in. Wow, those are crazy numbers. Okay, we can, let's see if this will help. We'll hit the math button. So notice, the B times A inverse got me an error. So I needed to rewrite that as A inverse times B. A inverse times B gave me 3 different values. These 3 different values are actually the A, the B, and the C. They look crazy to me. So if we look at the math and we use fraction, we'll see if we can turn those decimals into nicer fractions. Okay, it's not what I expected. Okay, not what I expected, but I'm going to look back and see what happened. Let's hit second matrix. Look at your A matrix. and hit enter, and you can actually see the numbers you typed in. I typed in 11. You're probably yelling at me, fix that. Well, didn't work out for me, did it? So we're going to go to second matrix, go over to edit, your A matrix. I need to go down and fix that to become a 1. Now that's correct. Some of you probably noticed that earlier. Sorry about that. So we'll get out by doing second mode, second quit. Matrix A inverse times matrix B. This is going to give us our calculation. There it is, so much cleaner. I don't know what was happening. -2, 2, and 6. A inverse times B gave us -2, 2, and 6. So what that means is we're -2x squared plus 2x plus 6 equals our y value. That's our equation. If you would want to type that equation into your calculator, you could see that the table produced exactly what we're talking about. At 0, it gave us a 6. At -2, it gave us a -6. And at +2, it gave us a +2. So that's a good way for you to check to see if your equation is correct. So to review that real quick, we took our 3 points and we wrote 3 equations. We cleaned up those 3 equations, converted them into matrices. We have this A matrix and a B matrix. The A inverse times B gave you your A, B, and C of the equation. The -2 was the missing A. The 2 was the missing B. And we already had predicted that the 6 was going to be the C. This next equation, we have a table. And we need to come up with an equation for finding what parabola fits this best. So we're going to take our graphing calculator and we're going to find the equation that fits those points the best. Well, you're going to go to the stat button. It's above the 8, it's above the program, up to stat. We're going to do this a lot, so this is really important. So you're going to go to edit, so number 1. Your x values are 0, 2, 4, 6, and 8. Your corresponding y values are 3, 28, 40, 37, and 26. So those are the points, and we can actually make them graph on in your window, and it's kind of fun and so forth. We're going to try to find the equation that goes through those. So we're going to hit stat again. Go to the stat button, which is above the program, above the cosine, above the 8. It's up there, STAT. Go over to calc. We are looking for what's called quadratic regression. This is a way that the calculator can calculate the equation that fits these points. Now, depending on which format of operating system you have, you'll have a different variety of this main menu here. Most of yours will have a couple different lines of information. You just need to be sure that it's talking about list 1 and list 2. Yours probably says it in a different order. You can most likely just go down to the word calculate, and it'll give you an A, B, and C value that represents the parabola that's going to match this. So y equals negative 1.55x squared plus 15.717, or let's round that up to 1/8, x plus 3.37. This is the quadratic equation that best hits these points. This revenue equation really goes to the next page. It's for price versus the number of items, or times the number of items. Items times price, or price times item. That would give you your revenue. So if your price is higher and you sell more items, your revenue increases. Okay, on the flip side, we're looking at a video store that sells 150 DVDs a week at a price of $20 a piece. So we're talking about revenue. And the revenue in that case, 150 times $20 a piece, gives you $3,000. Just for a guideline, we get $3,000. Well, the owner estimates that if he decreases the price of each video, he's going to sell more videos. He's actually going to sell 25 more videos for every dollar he decreases. So let's try that sum. For each dollar he decreases, he gets 25 more. So at 150, he's going to add 25 videos, and to his $20 he's decreasing by $1. So we're going to say 175 times our 19, and we make more money, 3,025. 3,325. Well, if he does it again, 25 two different times, and subtract $1 two different times, we're going to take 150 and we're going to add 25 twice, and we're going to take the 20 and we're going to subtract the $1 twice. We're making even more money. And we'll do it again. We can sell even more videos by decreasing by $3. Now we're at 3,825. Well, if we continue this forever, eventually our money is going to be so low that it doesn't matter how many DVDs we sell. So we got to find out where this is going to balance out. What's going to be the maximum X value? Well, we're looking at 150 plus 25 times some number. We don't know what that number is. 20 minus $1 so many times. We're adding the 25 the same amount of times as we're subtracting the 1. That's going to give us our revenue. So by going to our calculator, y equals, let's get rid of our previous one, we're going to take 150 plus our 25x, our $20 minus our 1x, and we can look into our table. And we can look over here and see that it's increasing up to 4,000, 41, 42. Oh, now it's coming back down. There it is. And because these are even, it's falling like a perfect parabola. This is your exact middle. So we needed to increase it 7 different times. So how can the owner maximize revenue? To maximize revenue, decrease the price by $7 to sell 175 extra DVDs per week. And our revenue would equal $4,225. Again, we notice that looking at our table, when our x value is 7, here's our equation that we used. When our x value is 7, 150 adding 25 DVDs each time, $20 subtracting $1 each time. If we do that 7 times, we'll get to a maximum number of 4,225. If you do it an 8th time, you start to decrease your profit and it starts to drop.